Today we will be learning how to find out whether the given set of vectors are linearly dependent or independent using the concept of rank. What we will be doing, we will be converting the given vectors in the column vector form, column matrix format. We will combine that and we will make a homogeneous system of equation, and then we will be trying to find out the rank of the matrix. If the rank of matrix becomes equal to the number of variables, that is number of scalars which we have taken in the equation, that if that number becomes equal to the number rank, then we say that given system of equations are linearly independent. If the rank becomes less than the number of variables, then we say that the given vectors from which we have made this matrix are going to be linearly dependent. Let us take an example to check whether the given set of vectors are linearly dependent or independent using the concept of rank. Let us take the question, check whether the vectors, first one they are saying it is 1, 2, 3, second vector they are saying 3 minus 2 minus 1, and third vector they are saying 1 minus 6 minus 5. We have to check whether these vectors are linearly dependent or independent. Are linearly independent or linearly dependent. In the solution part, first we will write let V1, that is first vector, 1, 2, 3, V2, that is second vector, 3, minus 2 and minus 1, and V3 as third vector, that is 1, minus 6 and minus 5. Now we have been given 3 vectors, so we will be taking 3 scalars. Let C1, C2, C3 are n3 scalars. We will be taking the linear combination, that is C1 V1 plus C2 V2 plus C3 V3, and we will be comparing that with the 0 vector, and our intention will be find out the values of C1, C2, C3. Now, in the place of doing the full procedure, we will be using the concept of rank here to check whether the vectors are linearly independent or dependent. So we will be converting this into the matrix form. C1 into the first vector 1, 2 and 3 plus C2 into the second vector, that is 3, minus 2 and minus 1 plus C3 into the third vector, that is 1, minus 6 minus 5 is equal to 0 vector in the column format. Is going to be this. We will write this as a system of equation. We will convert that 1, 2, 3, 3 minus 2 minus 1, then 1 minus 6 minus 5. Then we will be having C1, C2 and C3. We will be taking that as a 0 matrix, 0, 0 and 0. Now we will be finding the rank of this matrix. To do that, we will convert into the echelon form. That means below the diagonal we need to make them 0. So we are having the first element as 2, next element as 3. We will be making these 2 elements plus 0 using the first element of the row number 1, column number 1. That is 1, so operation will be very easy. R2 minus 2 times of R1 and R3 minus 3 times of R1 to make this 2 and 3 as 0. 1, 3, 1, C1, C2, C3 and 0. We are doing the operation on row number 2. The operation is R2 minus 2 times of R1. R2 elements are, that is 2 minus 2 minus 6 and 0. 2 times of R1, that will become 2, 6, 2 and 0. Here this is R1, we are multiplying this by 2. Now we have to subtract, sign will change. This is going to be 0, minus 2 minus 6 is minus 8, this is also minus 8, this is 0. So we got 0, minus 8 and minus 8 and 0 here. Now we'll be doing third operation on third row, that is R3 minus 3 times of R1. R3 elements are 3, that is 3, minus 1, minus 5 and 0. We have to subtract 3 times of R1. That is, we'll be multiplying row number 1 by 3. So 3 1 is 3, 3 3 is 9, 3 1 is 3, and here it is 0. We have to subtract, so sign will change. This will become minus, this will become minus, this will become minus, this will remain 0. Here 3 minus 3 is 0, minus 9 minus 1 is minus 10. This is going to be minus 8, this is 0. Now, here it is minus 1. Okay. We got the elements here 0, minus 10, then minus 8 and 0. Now again we will draw a line below the diagonal. This is minus 8 here. This is minus 10. We have to make this as 0 because to convert this in Echelon form we need the upper triangular matrix format, and to make upper triangular matrix below the diagonal all the elements need to be 0. That means this 10 need to be 0. To do that, here it is, we are having 8, this is 10. So the LCM of that 8 5s are 40, 10 4s are 40. So we can use the 40 as LCM. That is a common multiple actually. We will be doing RT, we will be multiplying this by 4, it will become minus 40, then we will subtract the 5 times of R2. Here we are doing the operation on row number 3. So row number 1 and 2 will remain same. We will copy paste row number 1 and 2. 1 is 1, 3, 1. Here we are having C1, C2, C3. Here it is 0. Now we will be writing row number 2, 0, minus 8, minus 8, and here it is 0. We will be having operation on the row number 3. We will be writing that operation is 4 times of R3 minus 5 times of R2. 4 times of R3. R3 we will be multiplying by 4. So it is here, this is R3. So we will be multiplying this by 4. So it is going to be 0, minus 40, 8 into 4. 8 4 is 36. That is minus 36 and 0. And 5 times of R2, this is R2 row here, we'll be multiplying this by 5, so 5 0 is 0, 5 8 is 40 with the minus sign, again 5 8 is 40 with the minus sign, and here it is 0. We are subtracting, sign will change, this will become negative, this will become positive, this will become positive, this will become negative. 0 minus 0 is 0, minus 40 plus 40 is 0, minus 36 plus 40 is going to be 4, and this is going to be 0. So we got here 0, 0 and 4 and 0. Now if we look at below the diagonal, all the elements are 0. Now from here we will try to find out what is going to be the rank. It is in the upper triangular matrix form. First row is non-zero, second row is non-zero, third row is also non-zero. Since it is in echelon form, and we will write since rank of A is equal to 3, number of variables. How many variables we are having? That is C1, C2, C3. We are having 3, both are same. Therefore, this given set of vectors are linearly independent. I hope you have understood. The very important point you need to remember here if rank of A is equal to the number of variables, that means it is going to be a linearly independent vector, and if rank is not equal to the number of variables, that means rank is less than the number of variables. In that case, it will be linearly dependent. Let's try to understand what is the concept behind that. Now, if we want, as we know, this is of rank 3. If we want to try to convert this in normal form, we are going to get an identity matrix of order 3 in this matrix. Is it clear? That means this will become 1, this will become 1, this will become 1, and the rest element will become 0. So from first row, we will be having C1, from the second row, we will be having C2, from third row, we will be having C3. Still, if you want to verify this one by using the basic rule, so I will be explaining that just below that, but it is not compulsory part for your exam purpose. So if we write in equation form, what we will be getting, C1 plus 3C2 plus C3 is equal to 0. From the second row, we will be having minus 8C2 minus 8C3 is equal to 0. And from the third row, we will be having 4C3 is equal to 0. Now, if you simplify this one, 4C3 is equal to 0, this implies C3 is equal to, this is equation number 1, this is equation 2, this is equation 3, and from 3, C3 is equal to 0. Substitute value of C3 in 2, what we will get? Minus 8C2 minus 8 into 0 is equal to 0. That means minus 8C2 is equal to 0. This is 0. 8 into 0 will become 0. So 8C2 minus 8C2 is equal to 0. So C2 will be also 0. We got C3 is equal to 0. C2 is equal to 0. Now we will be substituting value of C2 and C1, C3. Substituting value of C2 and C3 in 1. So we will be having, the equation is C1 plus 2C2 plus C3, that is C1 plus 2 into 0 plus 0 is equal to 0. See these two terms, this will become 0, this will become 0, so C1 plus 0 plus 0 is equal to 0. This implies C1 is equal to 0. Is it clear? So we have got C1 is equal to 0 is equal to C2 is equal to C3. It clearly indicates that the given set of vectors are linearly independent. Therefore, given vectors are linearly independent. So if we use the concept of rank, there is no need to do this much steps. We have got the answer here. These are the extra steps. So to avoid that, we can use the concept of rank. So here, by giving after just converting into echelon form, we came to know what is going to be the rank. So if we use the property of rank, we can save our time in finding that the given set of vectors are linearly dependent or independent. Always remember, when the rank of A is equal to the number of variables, vectors are going to be independent, linearly independent. And when it comes to the rank of A is less than the number of variables, in that case, the given set of vectors will be linearly dependent. In the previous example, which we did in the last video, that was the case of linearly dependent vectors, and this one was the case of linearly independent. So if you have not seen the case of linearly dependent using rank, you can see my previous video. That's all for the day.